Hey everybody, welcome back. We're going to tackle lesson 102 today, absolute value inequalities. I really suggest that you read through the lesson, page 420. Then you'll be able to see all the background information. I'm going to run through the examples quickly, but I think it's really important that you read the information. Basically, when we talk about the absolute value of x being 3, we know that the x is 3, but it could also be negative 3, couldn't it? Isn't the absolute value of a negative 3 equal to 3? Absolutely. So this is what we're going to be kind of venturing off from. Instead of equal, maybe we're going to have a less than, okay? So let's think about that. If the absolute value of x is less than 3, what numbers are we talking about? Well, 2 fits, right? And 1 and 0, right? The absolute value of 0 is less than 3. How about negative 1? That works. The absolute value of negative 1 is less than 3. Negative 2, that works. What about negative 4? Could we plug that in and it be true? No. The absolute value of negative 4 is 4. That's not less than 3. So with less thans, we want to get our starting point, all right, which would be the 3 and the negative 3. Now, I'm going to go ahead and put less than or equal to so that we've got these filled in. And we would want to include everything inside. Okay, we want a conjunction, don't we? Because we're saying that x is between 3 and negative 3. All right? Now, if x, the absolute value of x, is greater than, say, 4, all right, what numbers are we talking about here? Well, if we plugged in 4, 4 is not greater than 4, so I don't want that, but I could plug in 4 and a tenth, right? I could plug in 5 and 6 and 7. Those would all be greater than 4. So 4 is our starting point. Because we don't have the equal, we're going to have it open, and we're going this way. So then let's also think about on the negative side. Negative 4 would not work, but it is our starting point. Negative 5 would work. If I plugged in negative 5, the absolute value of negative 5 is 5. That's greater than 4. So do you see what happens? With greater than, I'm going to have disjunctions. I'm going to have x is greater than 4 or x is less than negative 4. And it works that way with every single inequality. So when your absolute value is less than a number, okay, then x is going to be between a and negative a. Whatever that number is. If it's 7, right? 7 and negative 7. If you have absolute value of x is greater than a number, then x is greater than a or x is less than negative a. And again, that works for every number. All right, so looking then at the examples. So on page 432, our first example, absolute value of x is greater than 2. All right, greater than 2. So you'd want to show me 2 as your starting point. You want greater than, okay, and then the greater thans, you're also going to include negative 2 and everything less than. Again, I could plug in negative 5. The absolute value of negative 5 is greater than 2. All right, the next example, okay, we already did that one, so I'm going to move forward. Example 3. Now this one's interesting. The absolute value of x is less than negative 4. Okay? The absolute value of x is negative 4. Can an absolute value of x be less than negative 4? No. Every absolute value is going to be a positive distance, right? So this is no solution. Okay? I hope that makes sense. Read that example. But you know that absolute values are distances. Distances are positive. So it's not going to be less than a negative. That makes no sense. It's an empty set. All right, now what about if I have this little rascal? Okay, this is example 5, 102.5. All right, now if I have a negative outside here, remember what I want to do to get rid of that is to multiply through by -1. Okay, if I multiply an inequality by negative, what happens? It changes, it reverses the sign, doesn't it? So this becomes plus, this reverses, and this is plus as well. So now we have the absolute value of x is less than or equal to 3. So in this case, like my first example at the beginning, I'm going to have a conjunction between 3 and -3. So the less thans are conjunctions, the greater thans will be disjunctions. Okay, and then the last example, you may have to do a little bit of algebra to solve these, and that's okay, you know how to do that. All right, so just if this were plain old x, we know we have to isolate that, so we want to add 2 to both sides. This cancels. I have a negative, or the opposite of the absolute value of x is greater than -3. Okay, I don't want a negative in front, so I need to multiply or divide. You could be dividing, it doesn't matter in this case. So we're multiplying through by -1. Oh, that changes every sign's direction. And so again, we have less than 3, so we're going to have -3, 0, 3. We want open circles because we're not including, and go toward. Okay, easy little lesson today. So do A and B, stop the video, do it yourself. I'll put the answers up here. Okay, so for A, as you can see, I added 9 to both sides. I multiplied through by a negative, which changed all my signs, and I have graphed it appropriately. Now B seems like a little tricky question, but it's really very simple. Think about it. The absolute value of x is greater than 0. So we don't want 0 because we don't have the line, so we're going to start there. We want numbers greater than 0. But this is a greater than, so we also want to go in the negative direction. We're doing a disjunction because think about it. -1. If I plugged in -1, the absolute value of -1 is 1. That is certainly greater than 0. So this then would be the graph for B. All right, easy little lesson. Proceed to Red Web to see your assignment, and I will check back with you tomorrow.